morning students, welcome back to computer science class. Today here I am going to explain you about the classification of programming languages. In the last class, as I already explained, what is the programming language? The programming language is nothing but the language which is used to communicate with the system. Okay, so here we have different types of programming languages, like if you want to communicate with another person, someone will communicate with the Telugu, someone will communicate with the Hindi, someone will communicate with the English. Only the purpose is communication. Okay, but they are using different languages. Similarly, here also we are communicating with the system, but using a different programming languages. So how the programming languages are classified? Here we have different types of programming languages. And how the programming languages are classified? The programming languages are classified in different ways. Okay, the programming languages can be classified into different ways according to the extent of the translation it is required to translate that programming language into a machine language. Okay, what extent translation it is required to transfer the programming language, whatever language is there, that into a machine language. Okay, so based on that, here we have a different types of programming languages. You can see here, programming languages is divided, it is classified into two types. One is a high level and the second one is a low level. Okay, so again, this high level is classified into three. First one is a procedural. You can say this, procedural, write down the running notes. Procedural. Second one is a non-procedural. And the third one is a problem oriented. Okay, first one is a procedural, the second one is a non-procedural, and the third one is a problem oriented. Now come to the low level languages. The first one is a machine language and the second one is a assembly language. Okay, so understood? So totally here, whatever programming languages are there, that are classified into two types. First one is a high level, the second one is a low level. Low level is divided into two types, machine language, assembly language. Whereas high level is divided into three types. First one is a procedural, the second one is a non-procedural, and the third one is a problem oriented. Okay, you write down this category because again in a procedural oriented we have three types. Again in non-procedural we have two types. Again in problem oriented again we have two types. That we'll discuss. Okay, now first we'll discuss about the low level, because in the low level we have only two types that we'll discuss as machine language and assembly language. See, low level languages are of two types. First one is a machine language and the second one is a assembly language. Okay, two programming languages we have, and already I have completed theory part of this. Explanation is also completed. What is a machine language? Okay, machine language is also called as a binary language. Binary language. Why it is called as a binary language means in this language we'll get only two bits, that is zeros and one. Okay, and this is also called as a computer language. Computer will understand only the machine language. So whatever information you want to pass to the system, computer, that information should be in the machine language, because machine language will understand only the, computer will understand only the machine language. So whatever data you want to store, whatever instructions you want to give, all those instructions should be in the machine language. And whatever code is there in the machine language, that can be directly executed by the processor, because the processor will understand only the machine language. So whatever code is there in the machine language, that can be directly executed by the machine language. There is no further translation is required for this language. And it is very friendly to a processor. Processor will understand only this one. And one more thing, it is whatever code you write inside the machine language, that will be executed very fastly and quickly, because it does not require any translation. Understood? Whatever you have given in the machine code, that directly is executed by the processor. It does not require any further translation. So that is why whatever you have given in a machine language, that can directly executed by the processor. So that is why it will increase the throughput of the system and it will decrease the performance execution time. Understood? So this is machine language. Only the thing is, it is a machine language is nothing but it is a system language. Whatever you want to store, whatever instructions you want to give inside the system, that should be in the machine language. And whatever code is there in the machine language, that can be directly executed by the processor. Only 3 or 4 points you can write it by your own, no problem. Now come to the assembly language. It is a little bit extension of the machine language. Because in the machine language, whatever you give like this, 0, 1, 0, 1, whatever you want to give, there should be the zeros and ones and all. But it is difficult to understand and difficult to remember also. If you want to store one character inside the system, example, you want to store A inside the system. A, the ASCII code of that is example 69. This should be converted into a machine language like this. So it required a process and you need to remember the code of each and every character. So it is difficult. So to solve a few problems, to solve a few difficulties, whatever you have in the machine language, here one more language is there, that is the assembly language. Okay, so it is an extension of machine language. Here, instead of using this zeros and ones, here we will use the symbols. Okay, symbols, and these symbols are called as numeric codes. Numeric codes. Okay, and in the last class also I have explained, if you want to perform addition, then how will you write? Add A, B. So what happened? A and B is added, and that information is stored in A. So here it will use the registers to store the value. Only the thing is, in the machine language we'll use the zeros and ones. In case of assembly language, we'll use the symbols. Clear? So it is very close to the machine language, but it is not exactly machine language. So again, whatever code is there in the assembly language, that should be translated into a machine language. Again, here we need a translation. Okay, it is very close, but it is not exactly. Okay, so that is why whatever you have given in the assembly language, that should be converted to the machine language. So in order to convert assembly language into a machine language, here we are using assembler. Assembler is a code, it is a program which is used to translate your assembly language code into a machine language. Okay, so compared to machine language, little bit assembly language is easy, but the difficulty is, again you need to translate your assembly language into a machine language. It required for the translation. But compared to machine language, it is little bit user friendly because you no need to remember all those binary strings. If you remember the codes, symbols, it is enough to write the program. Clear? Now, we will discuss about the high level language now. Okay, now all of you draw this high level languages. High level languages are divided into, classified into 3 types. First one is procedural. The second one is a non-procedural. The third one is procedural, non-procedural, problem oriented. Procedural, non-procedural, problem oriented. Again, procedural is divided into 3 types. First one is algorithm. Next, object oriented. First one is a algorithm, second one is object oriented, and third one is a scripting. Okay, first one is a algorithm, the second one is a object oriented, and the third one is a scripting. Now come to the non-procedural. The first one is a functional based. And the third one is a, first one is a functional based and the second one is a logic based. Now come to a problem oriented language. The next one is a problem oriented. Problem oriented is again divided into 3 types. Okay, first you write down this. Problem oriented, numeric. The second one is symbolic. symbolic, and the third one is publishing. First you note down this, then we'll go to the problem oriented. Under this procedural oriented, we have three types: algorithms, object oriented, scripting. Okay, procedural again is divided into three types: algorithms, object oriented, scripting. Non-procedural is divided into two types: functional based, logic based. Okay, what are those? I will explain. Now come to the third one. Here, problem oriented, numeric, symbolic, publishing. You take this. I know it is little bit big, but try to write. Problem oriented, three types: numeric, symbolic, publishing. Okay, you write down. I will explain one by one. Over. Now we'll discuss about the procedural. First we'll complete the procedural, then we'll go to the non-procedural. Okay, actually what are the procedural languages? Okay. Actually, procedure oriented, what happened is, whatever program is there, example you have 100 lines of program. That 100 lines of program is divided into different parts. Okay, and that parts should be executed in one order. Okay, so example, this is a part 1. It is called as a subprogram 1, subprogram 2. Subprogram 3, like this. Okay, so here first subprogram 1 will be executed, next subprogram 2 will be executed, and subprogram 3 will be executed. Means in the given procedure, in the given structure only, the program will be executed. Understood? So in a procedural oriented, what happened, whatever programming is there, that program is divided into different parts, and each and every part is executed according to the given order. Example here, this section is depends on this one. This section is depends on this one. Okay, so first this section should be executed. Next the second one will be executed. Next the third one will be executed. Means whatever subprograms are there, the total, as I already said, the total program is divided into different parts. And each and every part is executed in the sequence, in one order. Okay, so in this example, we are following like this order: 1, 2, 3. So it is a condition that first subprogram should be executed first, the next second one, next third one. Clear? So in the given order only the program should be executed. So it will help the programmer to structure the program. Okay, so we are only giving the order. So according to the order your program will be executed. It will increase the efficiency of the program. Clear? Procedure means we'll give one procedure, according to that only your program will be executed. Means we'll give the execution order. According to that order only your program will be executed. So this procedure oriented is divided into three types. First one is a algorithm, and the second one is a object oriented. Okay, and the third one is a scripting. Scripting. First one is the algorithm, the second one is object oriented, and the third one is a scripting. Clear? You note down this? Now we'll discuss about algorithm. Algorithm. See, in the algorithm, what happened is, algorithm means what? It is a step-by-step process. Okay, algorithm is nothing but it is step-by-step process which instruct the computer. Okay, which instruct the computer how to execute the program. Okay, so algorithm is nothing but we are giving a step-by-step process to a system, means how to execute a program. That information we are giving in the form of step-by-step process. Example, I want to calculate sum of two numbers. Then what we'll do? Example, in the step 1, read a comma b comma a comma only a comma b comma c. Okay, next a comma b only will take. Next step 2, store a comma b values. First we are reading a and b. Next we are storing values in a comma b. Next third step 3, add a plus b. Next step 4, print c. Actually add c equals to a plus b. Next print c. Understood? So here what we are doing, first we are reading a comma b values. A comma b, c also you can take, no problem. Next step, we are storing a comma b, means we are storing some value in a comma b. A value, b value we are storing. Next what we are doing, we are adding c equals to a plus b, means we are adding a plus b and storing in a c. So finally what we are doing, we are printing c. So it is a step-by-step process. So in this, if you want to shuffle, if you want to overlap any step, you won't get the required result. Example, if you want to print c first, then you want to take a and b value. It is not possible. Okay, so that is why algorithm is nothing but the step-by-step process which instruct the computer how to execute the program. Understood? It will instruct, but what it will instruct? The procedure, how to execute the program, you will get in an algorithm. Clear? Now, next point it is a top-down. Top-down. Okay, so starting to ending, it is a top-down approach. And here, on this algorithm, on procedure-oriented, here we have a different types of programming languages which are dependent on this. First one is a COBOL. Okay, COBOL language is based on this only. COBOL, Pascal. Okay, these two languages, Fortran also, and Fortran. These three languages based on the algorithms only. Means in the three languages, step-by-step process will give the compiler the program which execute your program. Okay, so for execution purpose, what we'll do, each and every step will instruct the compiler. Okay, so that it will execute your program. Only one thing is there, we are giving a step-by-step process. According to that step only, your program should be executed. That is nothing but the algorithm. Clear? To whom will give these instructions? Will give these instructions to the computer, so that computer can execute your program. Clear? And this is a algorithm. Now, what is the next one? Object oriented. Object oriented. So here instead of procedures, algorithms, in the object oriented, what we use is objects. And objects, what are objects actually? These are modules. Modules which contains, example, this is an object. Object contains different variables, values, and it contains methods which can be performed on this variable. Okay, so you can say that object is one module which contains different variables, different methods which can be operated on that variable. See here, I will give you one object, math object I will give. Okay, this is math object. In the math object, example, we have some mathematical function, square root, circle, example. These are the functions. Pi is a value, pi equals to 3.14. Example. So these are all related to mathematics. So all those functions, all mathematical functions and all mathematical variables whose value is fixed, that can be stored in one module, that is called as object. So that is our object is called as a data plus methods. Okay, data plus methods. Data is nothing but the pi value. Method is nothing but the example calculating area of circle. Area of circle. Okay, so area of circle is a example, it is a method. So this method can be operated on this variable. Okay, so all the mathematics related functions and all the mathematical related values are stored in one module, and that object is called as a mathematical object. So here if you want to calculate some area of circle, how will you calculate? Area of circle equals to pi into r square. Example, pi into r square I want to calculate. Then pi is already there, 3.14, r I am giving like this 5. Okay, but this area of circle is a function of from where you are getting this object you are getting, and from where you are getting that pi value, from that object only you are getting. Only the point is here, the variables and the methods which are similar in nature, all those are grouped into one place, one module, that is called as object. Clear? So object is a collection of data and methods. That methods can be operated on that variable only. For example, you have a string functions like a string lowercase, uppercase and all. Trigonometry functions. All the trigonometric variable and trigonometric functions are stored in one place, because that trigonometry functions can be operated on the trigonometric variable only. So that particular object, that particular module is called as an object. Okay, so only one thing here, object is a collection of data and methods. That methods can be operated on that data only, and all the related information are stored in one place. That is called as object oriented. So it is object oriented programming means here instead of the functions and all, the total program is divided into a number of objects, and whenever you want to operate particular method, just we'll call that object. Example, in the previous example what I have given, square root I have given. Square root is a method of math object, example, mathematical object. So if you want to use this method, what we'll do is like this, math dot square root. So you no need to write the total programming code. It is already built in code. So whenever you call this method, whatever variables are there and whatever variables are required for that, whatever instructions are required to execute that method, all those will be executed. Clear? Only this, for example, we have a string functions, mathematical functions we have, some general functions we have, some date functions we have, example. So all those functions are grouped. The functions which are having a similar nature, that are grouped. And the variables which are related to that particular functions are in that same location only. That is called as object. Okay. So here in the object is a collection of data plus methods which can be operated on that variable only. Clear? Now we'll discuss about the characteristics of object oriented. Means what advantages you have using this. Okay, first one is the abstraction, and the second one is the encapsulation, and the third one is inheritance, and the fourth one is a reusable code. Reusable code, and you have number of advantages using this polymorphism. Okay, these are the advantages of object-oriented programming. See, in the second sem, in the third sem, in the fourth sem, except this. Here just I am giving introduction part, but the complete the second sem, third sem, fourth sem, fifth sem, 99% based on this only. Okay, so if you are not getting anything here, you ask me about this in the live classes, because it's very important, object oriented. Except C programming, all the remaining programming languages what you have in the next coming semesters, all those based on the object oriented only, right? So it is a block which contains different methods and variables, and these methods can be operated on that variable. You try to remember that point only. Whenever you want to use that particular method, we'll call that. If you don't want to use the mathematical methods, we will ignore it. No problem. Clear? Now, see, one more example I will give. Here we have a physics, electronics, statistics branches. Understood? So, that what happened, if you want a physics student, we'll go to the physics class only. Similarly, if you want a mathematics, we'll go to the mathematics subject. If you want to go to the if you want string functions, then we'll go to the string object only. Like that. Understood? So, if you want to go to the next general function, then we'll go to the general object. If you want to go to the physics, we'll go to the physics. If you want to go to the statistics, if you want to go to the, it's a particular object. So whatever the students who want the statistics, they will join in the statistics. Okay, and the students, those who want the physics, they will join into the physics group. That is nothing but the object. Okay. In the next class, in detail, we'll discuss about this classification of programming language. Under classification of programming language, this object orientation we'll discuss. Okay, thank you.